Hi, this is Mrs. Often, and this video is going to be about classifying triangles and working with sides and angle problems. This corresponds to 4.1 and 4.2 in our green geometry textbook. The objectives are as follows. By the end of this slide deck, you will be able to classify triangles according to their sides and angles, solve algebra problems related to sides and angles of triangles, prove the interior and exterior angle sum theorem for triangles. We've done this already in class, so it's worthwhile for you to review this. Prove corollaries to these theorems. You will be asked to do this for homework. And prove the third angles theorem, another homework problem. You'll also be able to solve algebra problems related to interior and exterior angles of triangles. Let's begin by classifying by side lengths. There's three ways to classify triangles by side lengths. A triangle may be equilateral, that is, it has three congruent sides. It may be isosceles, in which case it has at least two congruent sides. So note that an equilateral triangle is also an isosceles triangle, but the converse of that is not always true. A scalene triangle has no congruent sides. We can also classify by angles. A triangle that is acute has three acute angles. A special type of acute triangle is the equiangular triangle. This triangle has three congruent acute angles. A right triangle has one right angle, and an obtuse triangle has one obtuse angle. So let's begin classifying each triangle by its angles and sides. We start off with triangle MNQ, which is acute and equilateral. Moving on, triangle NQP is obtuse and scalene. And finally, the large outside triangle here, MNP, is a scalene triangle, and we'll note that it is also an acute triangle. Finding side lengths, we're going to begin by noticing in this triangle that while every side has the variable x in it, only two of these sides are labeled as being congruent. It does look like this is an example of an obtuse isosceles triangle. So we're given that JK is congruent to KL. The definition of congruent segments tells us that their angles are equal, or their side lengths are equal in measure. We'll substitute. Then adding 10.7 and subtracting 2x from both sides gives us 2x equals 17 and no tenths. And dividing by 2 gives us x is equal to 8.5. We can substitute this value back in to the side length expressions to determine the side lengths of the triangle. There they are up at the top. JK is 23 3/10 units. KL similarly 23 3/10. And JL, the longest side, is 44 5/10. Looking at another problem here, FGH is equilateral. So we'll determine each side length. Now again, all three sides are labeled using the variable y. We can select any two of them. So we're going to start with FG and GH. Wouldn't have mattered if we had done like FG and FH, for example. But this just looks convenient because we have 3y minus 4 equals 2y plus 3. So this should be over in about one step, giving us y equals 7. Substituting in, we get all the side lengths are in fact equal to 17. This is a great way to check your work if you are trying to determine if you got a correct answer. If it says the triangle is equilateral and you get different side lengths, then you have done something incorrectly. Okay, here is an exterior angle problem. Now, we want to remember that the interior angles of a triangle add up to 180 degrees. However, the exterior angles of a triangle are equal to the sum of the two remote interior angles. So the measure of angle A plus the measure of angle B is going to be equal to the measure of angle BCD. So I'll go ahead and do that substitution so that we can solve for x on our way to finding the measure of angle B. And keep in mind, angle B is that angle that is labeled 2x plus 3. So we substituted everything in. Simplifying, then we're going to subtract 2x on both sides and add 60 to both sides. We'll be able to divide 78 by 3, and we'll get that x is equal to 26. Now substituting, we get that angle B is equal to 55 degrees. I can further check my answer by substituting that value for x in place of 5 times x minus 60, and that will give me an answer of 70, which checks with 15 plus 55 equaling 70. So again, another way to check your work. Here's another exterior angle problem. Notice that this is a right angle triangle. It can only therefore have 2 acute angles. So I have the measure of ACD is my exterior angle. That's what I want to find. 6z minus 9 is therefore equal to 2z plus 1 plus 90 degrees. And I'm going to get z equals 25. My answer of 141 for the exterior angle measure of ACD, again, can be checked. 90 plus angle A, if z is 25, is going to be 51. That adds up to 141 degrees. So I know I've done my work correctly. A couple of corollaries to the interior angle sum theorem. So we recall the interior angle sum theorem for triangles tells us that the angles in a triangle add up to 180 degrees. Some extensions for this. The measure of each angle of an equiangular triangle is 60 degrees. And the acute angles of a right triangle are complementary. So once you've done this, you should be able to prove these with a statement reason proof or a paragraph or flow proof. The third angle theorem tells us if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third pair of angles are congruent. So you should, again, taking this drawing, here's our hypothesis, given 2 triangles, triangle LNM, and triangle RTS with angle L congruent to angle R and angle S congruent to angle M. The conclusion is N is congruent to T. You should be able to prove this, again, in a 2-column proof. Okay, we may have overlapping triangles. It can be helpful in cases like this to redraw the triangles so it's clear what we're working with. So here's my really poorly redrawn triangles. There's G, I, J. There's K, F, and H. And by the third angles theorem, I can see that K and J are going to have to be congruent to each other. So let's use that as we start this problem. So our measures have to be equal. We'll do some substitution. Now, once we get to this point, y squared equals 20. We don't actually need to take the square root of both sides because these expressions show that k is 4y squared and j is 6y squared minus 40. So we do not need to take the square root in this case. So the measure of angle k is going to be 4 times 20 or 80 degrees. And again, we can verify with this 6 times 20 minus 40 is also 80 degrees. So we know that our work has been done correctly. 2 additional theorems here. Every angle has exactly 1 bisector, and every segment has exactly 1 midpoint. We can use this to draw auxiliary sets, which can help us in proofs later in the chapter. I hope this has been a useful introduction to classification of triangles and to using interior and exterior angle sum theorems. Thanks and have a great day.